Electric circuits come in handy for all kinds of things. Recognise this? Click the switch to turn on the socket. Household wires and cables, like this one, transfer electricity very efficiently. That means they won't lose much of the energy as heat on the way. The electricity flows freely from the plug and is transferred into other forms of energy in household appliances, like this toaster. Can you pop the bread down, please? The heating element is made from a special wire, very different to the power cable we saw just now. The wire in the heating element transfers lots of its electrical energy into thermal energy and gets very hot. Exactly what you need to make toast. Electric current can also produce light, like in light bulbs. Can you switch on these lamps? Energy-efficient bulbs, like the one on the left, use less energy than normal bulbs to produce the same amount of light. They also transfer less of their energy into heat. So the energy-efficient light bulb wastes less energy. Good! Electrical energy can do other things too. It can cause chemical reactions, for example. This happens in a chemical process called electrolysis. In particular, we're going to see how electrolysis breaks down water, H2O, into hydrogen, H2, and oxygen, O2. We need to put an electric current through the water, after first adding a little sulfuric acid. See those wires? They're connected to small metal plates called electrodes. Connect up the battery and we'll see how this all works. Where the electrodes come into contact with the water, chemical changes take place, producing bubbles of gas. Oxygen on the left and hydrogen on the right. This electrolysis produces twice as much hydrogen as oxygen. Hydrogen can be used as a fuel for cars, planes, and boats instead of burning fossil fuels like petrol. So using hydrogen could even help us to control global warming. Okay, moving on. Let's look at magnetism. In fact, electromagnetism. We can create a magnetic field just by running an electric current through a wire. Connect the battery to start things off. Good, it's working. Really, it's just that we can't see the magnetic field, but there is a way we can see its shape. A compass will point in the direction of the magnetic field. Take this compass and move it all the way around the wire and watch where it points. Well done. The electric current creates a circular magnetic field around the wire. We've wound this wire into a coil. Once the current flows through it, it will act exactly like a bar magnet. This is called an electromagnet. And if we put a piece of iron inside it to give the coil an iron core, the magnet will be stronger. Electromagnets are really useful because, unlike normal magnets, you can turn them on and off whenever you want. Complete the circuit to see this one in action. The ends of a magnet are called the north and south poles. Why is that? Well, the magnet acts like a compass, and if it was able to move, the north pole would swing round and point, to the north. What do you think will happen if you add more turns of wire to the coil? Yes, you get a stronger magnet. Want to make it even stronger? Take out that puny battery and use something more powerful. Electromagnets can be extremely powerful indeed. Okay, I think we're ready for a recap. Electrical energy in a wire can be transferred as heat. Electric currents can be used to produce light in light bulbs. Less efficient lights produce more heat instead of light. Electric currents can cause chemical changes. Electrolysis is used to break down water into hydrogen and oxygen. Electric currents can be used to make electromagnets. Electromagnets can be turned on and off with a switch. Time for a quiz. Question 1. What two gases are produced from electrolysis of water? A. magnesium and hydrogen, B. hydrogen and oxygen, C. oxygen and magnesium. Question 2. What is not true about energy-saving light bulbs? A. They use less energy than normal bulbs. B. They transfer less of their energy into heat. C. They are brighter than normal bulbs. Question 3. During which process would you use electrodes? A. Transferring thermal energy into light energy. B. Electrolysis. C. Measuring electricity. Question 4. What can we use to find the shape of a magnetic field? A. An electromagnet. B. A coil of wire. C. A compass. Question 5. Which of these will not make an electromagnet stronger? A. Adding more turns to the wire coil. B. Heating it up. C. Using a more powerful battery. Question 6. Complete this sentence. Electromagnets can be A. Used to break down water into hydrogen and oxygen. B. Used to create electric currents. C. Turned on and off. Good score! Get you!